I am continuing the question answer of chapter pressure, and this is fifth part. Let's have the question. First question, write down Archimedes principle. We can write this way. According to Archimedes principle, when a body is partially or completely immersed in a liquid, it experiences an upthrust equal to weight of displaced liquid. Okay, we have to be very careful that Archimedes principle is applicable for all the bodies, whether the body is floating or sinking or it is suspended in the liquid. In all the cases, it is applicable. So we can write a formula for this: upthrust or buoyant force. According to Archimedes principle, upthrust is equal to weight of displaced liquid. This is the heart of the Archimedes principle. But how can we prove that upthrust is equal to weight of displaced liquid? There is another question for this. The question is, verify Archimedes principle experimentally with necessary diagram and method of calculation. If you are told so, then you can make diagram this way. At first, the body should be weighed in air, and this is an object taken and is weighed in air. Then we have to manage a eureka can which is completely filled with water, and here we have a spout. If we immerse this object into the water, then certainly the displaced water comes out through the spout because water is completely filled in eureka can. So we have to make another arrangement also in which the displaced water should be collected in an empty beaker. So here empty beaker is taken at the top of the top pan balance. We have to draw another diagram also this way. In this diagram, something is different than the first. What is the difference? When this object is immersed into the water, then displaced water comes out through the spout and it should be collected in the beaker. This is displaced water. Now we have to write the values. The object at first was weighed in air. Weight of the object in air is, let's say, W1. Weight of the same object in liquid, let's say W2. And weight of the empty beaker is, let's say, W3. And weight of beaker plus displaced water is W4. Now why we did this? Because we want to prove that upthrust is equal to weight of displaced liquid. But how? I want to take this diagram to one of the side. And we have to write something about this experiment, then only we can verify experimentally. As shown in the diagram, a body is weighed in air. Weight of the body in air is W1. It is mentioned here. And weight of the body in a liquid, water is taken here, is W2. And empty beaker, W3. And beaker plus displaced water, W4. Now we can say that here upthrust is equal to W1 minus W2 because upthrust is the difference of weight in air and liquid. Is the upthrust exerted by the liquid on the body? So W1 minus W2 is upthrust. In the same way, weight of displaced water is equal to W4 minus W3 because W4 is the combined weight of displaced water and beaker, but W3 is the weight of empty beaker. That's why when we subtract this W3 with W4, we'll get weight of displaced liquid. What we get as a result of this experiment, experimentally W1 minus W2 and W4 minus W3 are found to be equal. It means weight of displaced liquid is found to be equal to the upthrust. Thus, Archimedes principle is experimentally verified, which states that upthrust is equal to weight of displaced liquid. Isn't it? Okay, this way we can verify Archimedes principle experimentally. Now let's have another question. Write down uses of Archimedes principle. There are many uses. Few of them are highlighted here. Number 1, to build hydrometer. Do you know what is hydrometer? It is a device which is used to measure the density of the liquid. Here, hydrometer is shown in the middle of this liquid. We have to release hydrometer vertically into the liquid with very loose hand, and when it stops to move, then we can see directly the value of density. The level of liquid coinciding with the value of density is the direct measurement of the density of the liquid. Now I want to remove this diagram. Another use to move submarine into the sea. Do you know what is submarine? Submarine can move in the sea, emerging into the seawater. This is a simple representation of submarine. Here, level of water is shown with this line, and at this time submarine is partially immersed. Here we have water tank, which are called blast tank. When it is filled with water, then submarine immerses into water. If we have to go downward, then the blast tank of the front side of the submarine is filled with water like this, and then submarine can move downward. But if we have to come upward, then the lateral part of the submarine should be filled with water. I mean to say, the blast tank should be filled with water and then it turn towards upward direction. This way submarine can move in the sea, and at this time it follows Archimedes principle. Let's have another use. To fly the hot air balloon. This is hot air balloon. A basket is at the bottom side. Look at this. People can sit in the basket, and if air is heated by certain heating device, then what happens? The air becomes lighter and off thrust on the balloon becomes high, and balloon flies up and up. If we have to bring it down, then heating is stopped, air cools down and balloon comes downward. This way it works. Let's have another use. To move the ship into the water from land. Ships are made on the land, and when it has to be moved to the sea water, then how do we do this? This is the method. A ship is being introduced into the sea, and it seems to be a little difficult at first, but it is designed in such a way that it uses Archimedes principle in such a way that it can be moved into the sea very easily this way. Okay, these are the major uses of Archimedes principle which we can write in the examination. Okay, let's have another question. This question is related to numerical problem. A diagram is given and numerical problem is given this way. Study the given diagram and answer the following question. First question is, what is the mass and weight of the stone in air? We can write the given information. Weight of the body in water is 15 Newton. It is given here. And another information, weight of displaced water or upthrust, here it is given. Weight of displaced water is told 8 Newton. We can consider that weight of displaced water is 8 Newton, isn't it? And then question is weight of stone in the air. We have an equation. The equation is upthrust is equal to weight of the body in air minus weight of the body in water in this case. Okay, now taking value, upthrust is 8 Newton. Because upthrust is equal to weight of displaced liquid, that's why we can take 8 Newton according to the given diagram. And weight of the body in air we are going to calculate. In water it is 15 Newton. That's why W air equal to 8 Newton plus 15 Newton is equal to 23 Newton. Just looking at this diagram also we can calculate verbally 15 Newton plus 8 Newton is equal to 23 Newton, but it will be better to have the equation also. Okay, now again another point is also asked. Mass, weight of the body in air is equal to mg. W air equal to m into g. Weight of any object can be calculated by the help of its mass and acceleration due to gravity. This equation can be used. W equal to mg. Now we are taking value. Weight in the air we have how much? 23 Newton. Mass we are going to calculate, and g we know 9.8 meter per second square is the average value of g on the earth. That's why we can use this value. And if we calculate mass dividing 23 by 9.8, we'll get 2.35 kilogram approximately, because only 2 digits after the decimal point is taken, other digits are cancelled, so approximately is written. We can write one sentence for our numerical problem. Mass of a stone is 2.35 kilogram approximately, and weight is 23 Newton. Here's another question also related to same diagram. How much of thrust is exerted on the stone? It's very simple, 8 Newton, because of thrust is equal to weight of displaced liquid, so 8 Newton. Okay, another question, in which principle the experiment based on? Write down the statement of the principle. It's very simple. This is Archimedes principle, isn't it? And we are going to write Archimedes principle. According to Archimedes principle, when a body is partially or completely immersed in a liquid, it experiences the upthrust equal to weight of displaced liquid. Okay, let's have another numerical. Here a table is given and the question is, different weight of a piece of stone on weighing it in 3 different media, air, water and aqueous solution of salt are given in the table below. Answer the following question. It means A, B and C are air, water and aqueous solution of salt, but which one is air, which one is water and which one is salt solution, we don't know. It's not given. We have to answer the question. Here is the question. Among A, B and C, identify water and aqueous solution of salt. It's very simple. The weight of the body will be maximum in air. We know this because upthrust of air is negligible, and its weight reduces in water, a little less weight in water. It means maximum in air means 20 Newton, weight B is air, and a little less in water, that means 17 Newton, C is water, but density of aqueous solution of salt is more, so upthrust is more. If upthrust is more, reduction of weight becomes more, so A is aqueous solution of salt. So we can answer this way, C is water but A is aqueous solution of salt. Another question added on it, if the weight of 1 kilogram mass in air is 10 Newton, find out the mass of piece of stone. Now we can answer very easily. Here the weight of a stone in air is B and that is 20 Newton is given here. And if the mass of 10 Newton in air is 1 kilogram according to this question, then the mass of 20 Newton of stone in the air will be 2 kilogram. Okay, now let's have another question. Find out mass of water displaced by the piece of stone. We know that upthrust of water equal to weight of the body in air minus weight of the body in water, isn't it? Now look at this, 20 Newton is the weight in air and weight in water is 17 Newton. That's why upthrust is 3 Newton. And we are going to find out what mass of displaced water. So we have to go forward. Upthrust equal to weight of displaced water and this is equal to 3 Newton. If 3 Newton is weight of displaced water, W equal to mg can be used to find mass of the displaced water. Weight of displaced water 3 Newton and m we are going to calculate, g 9.8 meter per second square. Now dividing 3 Newton by this 9.8 meter per second square, we'll get this result. What? This is equal to 0.306 kilogram. Now I want to stop. We did many question answer in this class also. In another class also we'll continue with numbers 36. Okay, I want to stop. Thank you.